We're the Ada team, and we wanted to create a predator versus prey situation and find ways to improve both algorithms to the point that interesting and intelligent decisions could be made on both sides.
For our first iteration, we tested the simplest possible scenario in which the predator always moves directly toward the prey and the prey always moves directly away from the predator. This baseline test demonstrates the inherent flaw in the prey's algorithm, in which it will run out of space and quickly be caught.
For our second iteration, we kept the predator the same and enhanced the prey. Instead of escaping directly away from the predator, we made our prey escape perpendicular to the predator. This worked surprisingly well, but with one downfall. When the prey ran into a wall, the predator quickly caught it.
With our prey being so successful at escaping, we felt a need to improve our predator's algorithm. We wanted to help our predator to look ahead and predict where the prey would be based on its previous movements. This algorithm was more difficult than we originally thought. As the diagram shows, we had to overcome inaccurate measurements and jagged movements by the sphero. We used an algorithm to generalize the data points and smooth the predator's decisions.
At this point, we decided to introduce decision making into the prey's algorithm. We gave the prey two options, to move left or right relative to the position of the predator. The prey was able to calculate its distance to the walls in either direction and use these measurements to make its decision. By periodically changing the prey's direction, it became more difficult for the predator to predict the future location of the prey.
We decided to have a little fun with our spheros and implemented a game of tag. We used our look-ahead predator and our decision-making prey. One started as it and chased the other. When the predator would catch the prey would then become the predator. The new predator would then give the new prey a second to escape before chasing.
Overall, we felt quite successful with the improvements we made. As mentioned at the beginning, our goal was to create a system where the spheres would make interesting and intelligent decisions, and although we succeeded at this, there is still plenty of work that could be done. Q-learning or a Kalman filter might improve both algorithms. Also, we wish he had the time and resources to create a much larger scale version where the spheres would have more room to be creative. This would also allow for exploration in team-based situations with multiple agents on both sides.